rahmatullahi wa barakatuh. Dear student of third secondary, today we are going to complete our solving for chapter 1, transition elements, and we will complete from the beginning of the chapter till before the general properties of 3D elements. Okay, we have today booklet 2 from pages 7 till 9 in Al Ustaz book. Let's start with our questions today. Let's start with our question. The first one, you have the number of moles of the following ions. We have different ions, the ion MnO4 negative, SO4 negative 2, also Cl negative, and the last one OH negative. The number of moles of the ion here, we have 1 of MnO4, 1 of SO4 negative 2, 2 of Cl negative, and the last one here will be OH3 from OH negative 1. Okay, if we discuss that our question, the 3p cation mole connected to what only? Okay, if we have 3p cation mole. Okay, let's discuss our question. We have here 3p cation. 3p means that we have the charge on the metal that we have like scandium. Okay, we have Sc plus 3. So the mole is connected to the 3 moles of the anion negative 3. So if we take 3 moles of hydroxyl here, what will be the result? It will be the right answer, letter D. So we have 3 moles of OH. In front of it, we will take 1 mole. Cation mole, that means that we take only 1 mole of the cation here. Okay, we take only 1 mole of scandium in front of 3 moles of hydroxyl. So that's the example here. We have scandium SCOH by 3. This is easy question, the first one. Let's go into question number 2. Question number 2 says that the highest oxidation state of 4b element. The highest oxidation state of 4b element, okay, found in the compound. We have different compounds here. Okay, we will discuss each one. We have MO2. Okay, it's just a symbol M. It's a symbol for any element of the 4b element. Okay, we have MO2. If we discuss the oxidation number of oxygen, we have oxygen divalent. So here will be the cation in front of it contains what? Contains 4. So it will simplify MO2. Another one. If we discuss that we have MO, so the cation here will be contain what? Contain 2. As we have M plus 2 releases in front of oxygen negative 2, so it will be in the group 2b, not in the group what? In the group 4b. So this is the wrong one. We have also here MCl2. We have here 1, we have M and Cl2. Cl2 here is monovalent and M will be divalent, so it will be also in the group 2b, so it will be wrong answer. The last one here we have SO4 negative 2 and M also will be plus 2, so all of them belongs to plus 2 or carry oxidation number plus 2, but only oxidation state for the element 4b element found in the compound what? In the compound this will be in the group or cation plus 4, and the rest of choices will be less than 4. We discuss them, we find them is plus 2. Okay, so the right answer here will be letter A, MO2. Okay, let's go into question 3. Question 3 says that it's very important question and we will discuss it completely in the chapter 5 in the organic chemistry, but we have here some of the uses of one of the elements that we use as a catalyst. Okay, we have here one that we use it as a catalyst in the Fischer-Tropsch method. We have the only one that we use, we have the iron as a catalytic factor or catalytic element. If we discuss the reaction here, it is possible to obtain what? By Fischer-Tropsch method. We have the charcoal, we have the plastic, the pure water, and the gasoline. Okay, we will take that. If we want to get one in the liquid state or to obtain one liquid, that material will be what? Will be at the first. We have here, we have nitrogen gas and hydrogen to obtain what? To obtain the ammonia gas. This is one that we take to get the liquid fuel by the Fischer-Tropsch method. Okay, if we take the answer, because gasoline is liquid, the right answer here will be letter D. Why? As we have here in the Fischer-Tropsch method that nitrogen in the presence of 3 moles of hydrogen as an iron as a catalyst, that will give ammonia. Okay, it is a catalytic agent here, iron, that converting a stream water gas, carbon and hydrogen into liquid fuel by what? By Fischer-Tropsch method. The liquid fuel here that we have will be the gasoline. The gasoline is a liquid fuel, while A and B here are solid fuel or solid materials, and also here pure water liquid, but not a fuel. We want to get obtain what? Obtain what here? Obtain a fuel here by Fischer-Tropsch method, that we get the one that we have will be the gasoline. Okay, let's go into question 4. Question 4 says that what is not used in the Haber-Bosch method? Okay, it is one also of the process that we have in our, that depend on the iron also as a catalyst here. Okay, if we discuss our question, that we have the depend on the Haber-Bosch method, we have the iron as a catalyst and uses pressure and heat in the Haber-Bosch method, that will be the reaction takes place between the hydrogen and nitrogen gases, not with oxygen. The only one here that we have suitable temperature, here we have high temperature or heat and high pressure also in the presence of catalyst will be the iron. So the one that is neglected here from our reaction, Haber-Bosch reaction, will be what? The oxygen gas. Okay, let's go into question 5. Question 5 says that the value of N in what? In FeCN by N. We have here the number N. We want the value here and brackets by -3. If we calculate the oxidation number, that we will put the oxidation states of the all the elements that we have, and at the end we will write equal neglected 0 and put instead of it we will put -3. Okay, which make the oxidation number Fe plus 3 is. Okay, let's discuss our calculation here. Okay, if we put the oxidation state here, we have the iron plus 3 and adding to it the oxidation number of Cn as a group will be -1, and we want to get N. At the end will be equal -3. Okay, if we put the other one here on the other side, we will take -3, and -N. So -N will give -3 and at the end, so N equals 6. Okay, it's easy for calculation, and I think boys will make it by looking at it as all. Okay, so the right answer here will be letter D. The answer will be 6. Okay, let's go into question 6. Question 6 says that the electronic structure of the ion X plus 4. Like what? Like argon. Then the element X is located in the vertical group will be what? Okay, we wanted to know the answer here. If we have element, and I think it's by looking at it, it's very easy question. We have X plus 4, and I think without discussing, we will find the element will be in group 3b, 4b, 5b, or 1b. Okay, let let's discuss our question. We have 4b element have electronic configuration of argon 18, 4s2, 3d2. Okay, so it will be in the group what? In will be in the here in the group 2b. But when it loses 4 electrons, when it loses 4 electrons, it becomes argon 18 only. So it will be in the group what? The element X located in the vertical group. It will be, it lose 4 electrons. So we have, it will be not in the inert element, as it will be in the group 4b. It will be in the group 4b. Okay, it will be in the group 4b as electron configuration illustrated. It will be in the contain 2 electrons in the d orbital and 2 electrons in the s orbitals. Okay, let's going to question 7. Question 7 says that in the compound HCl2, the metal cation contain 2 single electrons in orbital. So the metal is, okay, if we have iron, cobalt, zinc, and titanium. We want to discuss our question. If we have element that we put in the compound HCl2, it means that its oxidation number will be +2, right? Yes, okay. Oxidation number of X here in HCl2 will be +2. So it will be the binary titanium or divalent titanium has 2 single electrons in its orbitals or in the outer orbital. So we have the right answer will be letter D in our question. Okay, let's go into question 8. Question 8 says that the figure represents what? The number of period X and the number of main transition elements Y. In the following or in the long periodic table, we have 1 increases gradually and 1 by time without any change, and we have also 1 that not make any change and 1 decreases by time. Okay, we have the number of period. If we are discussing increasing of the cycle or period number, increases the number of main transition element. Okay, if we discuss that we have the number of electron increases, so the number of cycle or period number increases, and it will increases gradually as its direct relation between the cycle number or period number and the main transition element in the long periodic table. It's a direct relationship between each one, between the period number and the main transition elements. Okay, so the right answer will be letter A here in our question. Let's go to question 9. Question 9 says that the student record what? The student record in his notes the following hypothetical compounds in preparation. Okay, it will prepare someone for making or buying the some chemicals in for the lab. Okay, from laboratories, and the material that student can be obtained is, okay, we need a substance that student can deal with it. We have the first one here that we have copper tetrafluoride, and we have scandium dichloride, we have zinc sulfate, and the last one ferric chloride. Okay, so if we discussing each element, we have letter A, B, C, or D. if we mention that we have a material that we can get without any harmful effects, that we have oxidation number of element that will depend on it will be plus 3 in the compound. This is will be the more stable one. While in, if we discuss letter A here, we have a copper and it doesn't take oxidation here in this state. It will have the oxidation state plus 4. There is no oxidation state that we take here. We take plus 3. Okay, so it's a wrong answer. In B, scandium doesn't take plus 2 oxidation state. Okay, also it is a wrong answer here. And C, zinc, we have doesn't take the 3 oxidation state. Okay, so these compounds are wrong one. These compounds are wrong one in the chemical formula. Okay, these compounds are wrong in the chemical formula as they didn't have this oxidation number. But the one that its oxidation state right here that we have will be iron 3, Fe plus 3, that we of the cation iron, that will make exchange with the chlorine Cl negative, and the compound will be correct here. Its formula will be correct. Okay, its formula will be correct, will be iron 3 chloride, or we can say ferric chloride. So the right answer here will be letter D. Try to concentrate when you mention the chemical formula. Try to discuss all the choices that you have. Mention that slowly when you answer to get the right answer here. Okay, it's very easy, but make mistakes. Some of you make mistakes for it. Okay, let's going to question 10. Question 10 says that the soldiers use in their factories the element X, and the doctor use it also in his job X oxide. So X is one of them that soldiers use them in factories, and also the doctors use it in their jobs as in the form of oxide or the compound. What will be the element X that we have? Okay, we have here one that depend on it, one of the strongest element that depend on it and use in the manufacture of aircraft, also in the form of dioxide that we use in the sun protection products. We have the titanium used in the manufacture of aircrafts, and also titanium dioxide used in the manufacture of aircraft sun protection compounds or products. So it's not will be the iron, copper, or A and B. So the right answer here will be titanium, letter B. Okay, let's go to question 11. Question 11 says that the non-transition element that located at the right or the left of the 3D series are. We have the 3D series that at the left and at the right of the transition element we have the representative element. Representative elements that belong to one of the our choices here. We have K, Zn, and Ca. Here we have one of them that not belong to representative element Zn. Also here we have Br, Zn, and Mg. We have also Zn not from the representative element. So it will be transition. Okay, we have Hg, mercury, Zn, and cadmium. Also we have here two of the transition elements. The last one of our choices here we have K, P, and C, potassium, phosphorus, and carbon. All these elements belongs to the representative elements only. All these elements belongs to the representative element. K, B, and C contain zinc, doesn't contain zinc in the 3D series, where zinc is not located at the right or the left of the 3D series but falls within it in the transition element. So all of them are not transition element that located in the right or the left of the periodic table. We have here our choices will be letter D, potassium, phosphorus, and carbon. That will be the right answer here. Okay, let's go into question 12. Question 12 says that, okay, we have the number of 3D elements that contain the sub-energy level 4s1 in the atomic state equal to what? We have here the elements that we have equal to A, B, C, or A and B will be the right answer. Okay, if we have the 3D element contain sub energy level 4s1, this means that we have only one electron. Okay, so its structure will be 4s1 in their electronic structure. We have here two elements that we have two elements that located in the B series or in the B groups of the transition elements. So if we discuss it, we have chromium and copper have in their electronic structure, we have two have the electronic structure what? 4s1. So we have the number of elements, 3D elements contain sub-energy level 4s1 in their atomic state equal to not A or C or A and B, and the right answer here will be B, because chromium and copper have in their electronic structure 4s1. We have B means that we have only one electron, or we can say 1B. We can say 1B. Okay, that we have only one electron in the what? In the s orbital. Okay, so we have here number of 3D elements that we have 4s1 in the atomic state will be more than 1. Okay, let's go into question 12. Okay, question 13. Yes, that the single electrons in the orbitals we have here double their number of Ti plus 2. Okay, we have our choices here: iron plus 3, iron plus 2, manganese plus 2, and copper plus 2. Okay, we have the single electrons in the orbitals. We have double their number. If we have Ti plus 2, if we discuss the answer, we have the number of single electrons will be Fe plus 2. Fe plus 2, the number of single electrons here, we have 4 single electrons in the Fe or iron plus 2. In the case iron plus 2, that we have 4 single electrons, and it will be double to the number of single electrons present in the case of iron Ti plus 2, that equal be 2. Okay, so it will be double for the number of single electrons. In the titanium plus 2, we have 2 single electrons. Doubling to it will be iron plus 2 will be 4 electrons single in the orbitals. Okay, so the right answer here will be letter B. Let's going to question 14 says that the durability and hardness of the titanium. Okay, durability means it can be shaped or it can be easy to make shapes for it, and hardness of titanium greater than that of. Okay, it's easy question that depend on understanding of you. Okay, we want to discuss each one. We have the pure manganese, the aluminium, the pure iron, and all of the previous. If we discuss each of one regarding to or in the opposite to it, titanium, what will be the right answer? Okay, we have here titanium very hard as steel. Okay, so we have pure manganese will be brittle. So it will be the titanium here higher in titanium here higher than pure manganese in the hardness. Okay, and if we discuss pure iron, relatively soft, so it will be also less than titanium in the hardness. The last one here, aluminium doesn't maintain its strength, as it will be so not easy in durability, or we can't make it easily in making it a shape, but we adding some metals to it, so its hardness or flexibility or hardness, as it will be also very tight or very brittle comparing to the titanium, so its hardness less than the titanium. As we said that we, if we comparing the durability and hardness of the titanium, will be greater than pure iron, than pure manganese, and also the aluminium. So the right answer will be all of the previous. The right answer will be letter D, all of the previous. Okay, let's go into question 15. Question 15 says that the gold in the oxidation state plus 2 contain. Okay, we have gold in oxidation state plus 2. We have gold Au, and its atomic number 79. It's atomic number 79. But in case of iron, in case of gold plus 2, that it will be loses 2 electrons. So it will contain which number single electrons in its orbitals? We have 1, 2, 3, or 4. Okay, if we have the gold here, that gold or Au, its atomic number 79. We have xenon 54 in its electronic structure, 6s1, 4f14, and the last one here will be 5d10. Okay, so if we loses or make it in the oxidation state plus 2, in oxidation state plus 2 here, so we have which number of single electrons that we have in its orbitals, means by changing it into ion, how many the number of single electrons that we have in all of the orbitals in case of the ion plus 2. We have Au plus 2, we have containing Au plus 2, we have xenon 54, and also 6f0, 4f14, and the last one here will be 5d9. Okay, so it loses 2 electrons and its oxidation state plus 2. So we have here only 1 electron. We didn't want what is the number of electrons that we lose. Oxidation number plus 2. So we lose 2 electrons. One from S and the other from what? From D. And what is the number of single electrons in all the ion as all? The number of single electrons here we have in the d orbitals, we didn't have 10 electrons, so we have only one single electron that present in the d orbitals. D orbitals that we have 5 orbitals, each one contain 2, except the last one that contain one single electron. So we have here in the cases of oxidation number plus 2, the gold contain one only single electron in its orbital of the 5d in the gold. Okay, let's go into question 16. Question 16 says that choose what suit from the following statement to the atomic number of the element in case of its third ion is 24. Okay, if we discuss this question, we have the ion here that it's an active element. Okay, but we have the element that depend on it. If we discuss the answer, we have one element that radioactive or very active element. It will be what? It will be cobalt 60. It will be cobalt 60. So it depends on it. We use it in what? We use it in different uses that we have. The in case of third ion means that it loses, or we have atomic number 24. We have the cobalt 60 in detecting, we use it in detecting cracks, welding joints, as well as in the diagnosis disease such as cancer, and the checking of the quality of product. All of these are the uses of what? The uses of cobalt 60. So it will be its radioactive isotope that we use in the medical and industrial applications, depending on the number of electrons. Here we have 24, it will be cobalt 60. So the right answer will be letter C. The right answer will be letter C. Let's go into question 17. Question 17 says that the most of the 3D elements are similar in. Okay, most of them having what? The atomic number? No, all of them increases gradually in the atomic number. Their oxidation state +2, they have different oxidation states. Okay, having the highest oxidation state, it will be some of them reach high and some of them will be low, from the +1 till the +7. The number of vertical groups, they have one of them that present in the three vertical group, forming one group. But in the most of them, we not say all of them, we said most of them of the 3D elements are similar in. Okay, if we discussing it, most of the 3D elements take oxidation state, which is the more stable one, will be +2, or it will loses 2 electrons. So most of them are similar in the oxidation state. Their oxidation state will be what? +2. So the right answer will be letter B. Let's go into question 18. Question 18 says that the 3D element that contains electrons, we have the electronic configuration here, we have 2, 8, x and 2 in its main orbitals. So x equal what, and the element used in what? Okay, if we discuss the number of electrons here that we have, kind of element that we use it in a different different properties or different functions. Okay, if we subtracting what we have 3D x, if we collecting all of these, we have 2, 2 and 8. If we subtracting or substituting for x 15, we have here the rest of this 15, the atomic number will be 27. The atomic number will be 27. Okay, the 3D element, it will be present in the 3D series, and we have here x, substituting it or remove x and putting 15, we will have the atomic number at the end will be what? If we put the x, remove x and put 5, will be giving the atomic number as all will be 27, which is the cobalt that used in the manufacture of the magnets, and also by substituting it, we have the numbers 3, 5 and 13, the atomic count of a non-transitional element. Okay, so we have 1, 15 and 1 will be 5, 1, 15 and 1 will be 5 in replacing them. So here if we put 15, not giving the right answer, and what will be the right answer here? We wanted to get what? We wanted to get the element that not or contain 2x, 8, and x. At the end we have 2 electrons. Okay, that we use it in what? Okay, we have element that transition and that present in the elements that we use, that we have 5 in x, that the manufacturer used in the manufacture of electric cables. We have the right answer here will be letter B, that we have letter B is the right answer, and this is the element will be here the cobalt that we use it as x will be 5 in replacing it in the oxidation state, that we get 5 and used in the manufacture of electric cables. Okay, let's go into question 19. Question 19 says that choose the correct that represent the manganese. Okay, what will be the property here will belong to the manganese in its oxidation or reaches to maximum oxidation state. Okay, manganese can reach to maximum oxidation state plus 7. Okay, yes, it's one of our choices, but also in the presence of the earth's crust or the abundance of the iron will be greater than or less than the manganese. Okay, here manganese its effect that making in the medical field that it will be making or lowering the blood pressure. We use it in the treatment for the people that has high blood pressure, that we use, or high sugar, sorry, high sugar level, that it will lowers the sugar level if increases in the what, in the blood analysis. But here we have the another one, the presence of in the earth's crust, we have the iron greater than or less than the manganese. Okay, in comparing, we know that the higher one in the earth's crust or the fourth element in from the metals that present in the earth's crust as whole will be the iron. So we have here the manganese will be less than the iron. If we take the point of comparison in choice A and C, we have here choice A and C will be right, but the right one will be letter A, as the abundance of manganese in Earth's crust will be less than the iron. So the right answer will be letter A. Okay, let's go into the last question of our booklet today, question 20. Question 20 says that choose the correct answer here, and we have the 3D element that contains single electron in their orbitals. Okay, we have n minus 1d and ns. If we are in 3D, so we have n minus 1 and we didn't have 2d, but we have 2n. Okay, we have 2 what? We have 3s. Yes, so we have our choices here means that element located on the far left of the series, or the element are able to magnetizable like iron, maybe one, it will have 3, it will be, or it contains 3s. It's 3s means that it will have not like iron as all. Okay, the element soft and brittle metal, maybe, but we have here one of them will be in the 3s, it will be not brittle but soft element. Okay, but not very bright or brittle metal. The last one here, the element non-transition. If we are discussing that we have 3s element, that we have only one electron here, we have only one electron, so all transition elements contain one or more electrons in their orbitals. So the right answer here will be the element that not contain single electron in their orbital, that will be a non-transition element. The element, 3D element, that not contain single electron in their orbitals, n-1d and ns. This means that it is a non-transition element because all transition elements at least contain one or more electrons in their orbitals, and here we haven't any electrons in d or in s, so it will not belong to what a transition element. It will be a representative element. This is the last question of our booklet today. Okay, I hope you enjoy our question. I think it's sometimes hard, but you have to study hard before solving any questions. Okay, thanks for joining. I hope you understand every point. We can solve a lot of questions in our book, El Ustaz book, and we hope you can study hard and you can solve a lot of new questions. Please try to look at the Egyptian Knowledge Bank, and it's very difficult question in discussing like our questions. Okay, waiting for you in another booklet. Okay, thank you, Dr. Shireen, with you. Thank you and goodbye.